A bar B C bar plus A bar B bar C bar plus A B bar C bar plus A B bar A bar B C plus A B C plus A B bar C. Okay, so can we try to implement this expression using AND OR gates? Yes, we can implement, but you know, as it is a large expression, you are going to get very large circuit, right? So instead of getting the large circuit, we can able to simplify the expression so that the same kind of outcome we can able to get with the help of very less small circuit. So what you can do here, try to reduce this expression. What you can observe between these two terminologies? Can I take the A bar C bar as a common? A bar C bar common. Right? If I take A bar C bar common, you are going to get B plus B bar. B plus B bar. Right? Now try to do some kind of common terminologies. So can I do here the common terminologies as BC? Yes. If I take BC as a common, you are going to get A bar plus A. From these two, can I take anything as common? A B bar. You are going to get again C bar plus C bar plus C, right? So if you are going to solve it, you are going to get A bar C bar plus BC plus AB bar, right? Now try to tell, is there any way to solve this expression? No. I think we may simplify it, right? If you are able to observe, if you are able to observe, is there any chance? Is there any formulas can we able to apply? I think if you would like to apply, it should be in the form of at least distributive form, A plus BC form. Is there any A plus BC form? No, every combination contains two literals, right? If it is every combination contains two literals, it may not be possible to again simplify the data maximum extent, right? So this is my final non-redundant expression. Non-redundant expression. What is the meaning of non-redundant expression? I cannot able to remove any kind of literals from the expression. That is what I can call it as non-redundant expression. Okay, fine. Now for this Boolean expression, can I able to implement circuit? Yes, we can able to implement. Okay, so try to observe one more way. One more way. I am going to write the same operation. I am trying to take out the two common terminals as like A bar C bar. I am going to get B plus B bar plus. I am going to take out BC as common. BC as common. Then I am going to get A plus A bar or A bar plus A. Is it okay for everyone? Yes. And what are the remaining two terminologies? A B bar C bar and A B bar C. I didn't done anything for these two. Okay, fine. Now try to solve it. You are going to get A bar C bar plus BC plus A B bar C bar plus A B bar C. B bar C, right? Now try to do with these two and try to do with these two, right? If we try to do with these two, what will happen? What is the common terminals you can able to observe? C bar. C bar, right? If I try to take out the common C bar, you are going to get A bar plus AB bar. If I try to take out the common as C, I think C, you are going to get B plus B bar A. What is this one? Again distributive property, right? So C bar into, so I think if you are going to distribute it, you are going to get A bar plus B bar plus C into A plus B. I hope you understood, right? If you are trying to distribute over the terminologies, A bar plus A into A bar plus B bar. So A plus A bar is 1, so you will get like this. Okay, now try to like again apply the distributive property. You are going to get A bar C bar plus B bar C bar plus AC plus BC plus BC, right? Now is there any chance to decrease this expression? What we can do? Can we take What we can take? Okay, so I can take C. Even I can take C. It is again converted into other form, right? See, my aim is to make as every expression should be implemented form. So it should be in and/or form or it in and form, right? If I am going to take out the common as C, you are going to get C into A plus B, which is again expression as combination of both sum of the products as well as product of the sums, right? So I can say that this is my again one more non-redundant expression. One more non-redundant expression, or I can call it as irredundant expression also. Irredundant expression meaning that I couldn't able to reduce further, right? So is there any solution further? If it is any there, you can tell me, no problem, right? Finally, I would like to conclude here is, if you are going to solve it in one way, you are going to get one solution. If you are going to get in solve in one way, you are going to get some solution. If it is going to solve by someone, they may get some kind of another expression, some like k. Am I right or not? Finally, the result is same. At any cost, result is same. But how the cost of the implementation? What about the area of the digital board? What about the cost of the implementation? If you are going to consider all these design parameters, the expression which is having very minimum number of terms, which is going to occupy less area, less cost, right? So you have to find out a solution to that, right? So as a as a designer, you have to solve like this, right? But at certain situation you may get this as a result, certain situation you may get this as a result, certain situation you may get this as a result, but it should not happen, right? Whether you are going to follow any kind of approach, you should have to get only one simple result, right? For that reason, we are moving for another kind of procedure, that is k-maps. So from this time, you don't need to by heart any formulas, anything. You can just simply go through some procedure.